Well, hello. We're going to do a brief review of finding the equation for tangent lines. So here we go. To find the equation for a tangent line, you need two things. You need a slope. You need at least one point. Now you can find that one point a variety of different ways. If you're given a function to work with, which is the typical scenario, you could plug in a given x value to find the y value, and thus you have a point, xy. Sometimes you're given the point to start with, and that's even easier, so you can just kind of say thank you to whoever made that question and move on. And then to find the slope, typically, especially in calculus, that requires a derivative. Because remember, a derivative is just a slope. It's either a slope at a specific place, or it's an equation that finds a lot of different slopes when you plug in different x values. And once you have that information, we have a couple different equations. Y equals mx plus b is a popular one, which is slope-intercept form. Or y minus y sub 1 equals m times x minus x sub 1. I should specify that this point is actually labeled x sub 1 comma y sub 1, which matches with these labels over here. You can plug these in the slope-intercept form equation as well. You could technically put a 1 here and here, I suppose, but you usually don't do that. So you have those two options to work with. They each have their pros and cons. The example that we're going to do together asks you to end with slope-intercept form. So we might just use that going into it. I haven't quite decided that yet. We're going to decide that in the next minute or so. But the slope again is m, which you'll see here in both equations. Okay. So I need those two things. I can plug it in and find my equation. Let's do an example. Alright, so this is problem number 5 from the homework tonight. We're given a function, f of x, equals negative x to the third minus 11x squared minus 35x minus 31 at the point negative 2, 3. This is one of those times where I say, thank you for giving me the point. If I was just given, let's say, at x equals negative 2, well, I would have had to take that negative 2 and plug it in my function, which would then put it into every x value, with parentheses, of course, to be careful with the sign. And it would have spit out f of negative 2 equals 3. So I have this point, negative 2, 3. We didn't have to do that. You could plug that in to verify it if you want. If you don't quite believe the y value is 3, go for that. Just push pause and check it yourself. Otherwise, here it is. You could also have graphed this function and just found in various ways what that point was. But the bottom line is, I have a point. That's one thing that I needed. I needed at least one point. Got it. Now I need a slope. Well, I can take the derivative. Increase a little space over here. Y minus y sub 1 equals m times x minus x sub 1. Alright. The derivative, f prime of x, is going to be negative 3x squared minus 22x minus 35, and that's that. I'm actually looking for the tangent line at this point, so I have to use that x value in this function. So I'm looking for f prime of 2, so let's do that. Negative 3, plug in, oops, sorry, negative 2, there we go. Negative 2, quantity squared, minus 22, times negative 2, minus 35. And then I'll say, Addie, who's a student working here, can you please plug that in and find a y value for us? I'm going to do it by hand, we'll compare answers. Interesting. Thanks for confirming that. It's funny how that's similar to the actual point itself, which is kind of random. But anyway, so what this is telling me is this derivative is finding my slope, m. So each of these equals m when x is negative 2. So at that specific spot on my function, this is the slope that I need. So I ended up finding the two things that I needed, right? I have a point, I have a slope. That's what I need to write the equation for a line. In this case, a tangent line. Let's do that. Now, when I'm given a point and a slope, I would recommend using the point-slope formula. We can get into why that is more later, I suppose, but let's do it. I'm going to do a quick label here, x sub 1, y sub 1, and there's m. I'm going to start by writing my equation, y minus y sub 1 equals m times x minus x sub 1. Alright, let's plug in things that we know. I don't know my generic y, but y sub 1 is here, so minus 3 equals slope negative 3 times x minus a negative 2. Minus a negative, write that as plus a positive. I'm going to distribute the negative 3, negative 3x minus 6. Adding 3 to both sides, end up with y equals negative 3x minus 3. So again, it's good to stop and think, so what did I actually find? Well, I've got an equation for a line. It is in slope-intercept form. It has a slope of negative 3, crosses the y-axis at negative 3. And it is the tangent line to this function when x is negative 2. So there you have it, a little review of finding the tangent line equation, or rather the equation of a tangent line at a given point on a function. I hope you found that helpful. Have a great day.